Hello, welcome to Sunday Maths. The problem we have today is an example of exponential equation. Now, for those who are familiar with exponential equation, we know that this equation is going to lead to a quadratic equation. Now, I saw many solutions, and I wasn't seeing the quadratic equation. But let's delve into the solution. But before then, it is important to know that we're going to be using some laws of indices in solving this problem. So I'm going to remind us of these laws. First, we need to recall a raised to power x times a raised to power y is equal to a raised to power x plus 1. Secondly, a raised to power x divided by a raised to power y is equal to a raised to power x minus y. Also, a raised to power x all raised to power y is equal to a raised to power xy. Okay, having recalled this, let's solve the equation we have. 3 raised to power 2x plus 1 can be written as 3 raised to power 2x multiplied by 3 raised to power 1, which is same thing as 3, plus 3 raised to power 2x divided by 3 raised to power 1, which is same thing as 3, equal to 270. Also, 3 raised to power 2x can be written as 3 raised to power x all raised to power 2. Now, don't forget I'm multiplying it by 3 plus 3 raised to power x all raised to power 2. Now, divided by 3, I can write this as over 3 equals 270. Okay. From this point, I can choose to multiply through by 3 because I want to do away with the denominator. Multiply through by 3. Now, if I should do that, if I multiply through by 3, I'm going to be having 9. That's 3 times 3 is 9. So 9 multiplying 3 to the power of x all to the power of 2 plus, now the 3 cancels out the denominator of 3. So I'm going to be having 3 to the power of x to the power of 2 equals, now 3 times 270. That gives 810. So at this point, I can say let 3 to the power of x equals, let's use a variable, let's say p, for example. So you see, this becomes 9p to the second power plus p to the second power equals 810. Okay, now it has become simpler. Now 9p squared plus p squared, that gives us 10p to the second power equals 810. Now this is a quadratic equation I was talking about. So we can divide both sides by 10. Now doing that gives 10p to the second power divided by 10 equals 810 divided by 10. So it means p to the second power is equals 810 divided by 10, that gives 81. So I can now say that p, okay, take the square roots of both sides. If I take the square root of both sides, I'm going to be having, take square roots of both sides. So I'm going to be having p to the root of 81. So we can say that p is equal to plus or minus 9. Now don't forget, what we're looking for is x, not p. Recall, okay, I think I can do that here. Sorry, let's just use this space. Recall that we say 3 raised to power x is equal to p. So we already got p to be equal to plus or minus 9. So p is equal to plus or minus 9. So let's take it one after the other. When p is equal to positive 9, when p is equal to 9, so it means we have 3 raised to power x equals 9. I can have this as 3 raised to power x equals 3 to the second power. This goes, it means x is equals 2. That's the first value of x I can have. Now, when p is equal to negative 9, what do we have? Let's use this space. When p is equals negative 9, I'm going to be having 3 to the power of x equals negative 9. Is there any number to the power of anything? Is there any number 3 to the power of whatever number to give negative 9? There's no number. Remember, what we have is negative 9, not just 9. So there's nothing. Now, do not do the mistake of having this to be maybe negative 3 to the second power? No. If you should use this, you are going to be having 3 to the power of x equal to negative 3 to the second power. Now, what you have here is not to the base of 3. So what does this imply? It implies that for p equal to negative 9, there is no solution. There's no solution for this part. So if there's no solution, we can conclude that our x is equal to 2. You see this matter? All of us will learn it. So for this equation, our x is equal to 2. I hope you understand. If you have any contribution or you are not clear with anything, please drop in the comment section and I will do well to attend to it. Thank you. Bye. Until next time.